Hello, and welcome to the lesson today about the mole and conversions. My name is Kristina Kohuth, and I'm going to be your narrator for today. So, let's talk about the mole. I'm not talking about the animal. I'm talking about the scientific unit of measurement for the amount of a substance. So, the mole is defined as I just said, and it is equal to Avogadro's number and was determined using the element carbon as a standard, like in many other equations and systems for measurement using atoms and things like that. They all use carbon as a base, so it's easier to remember. We can use a mass spectrometer, and that will count precisely the number of atoms, and that's how we would determine mole. And what I find can help you remember mass spectrometer is if anybody watches NCIS or CSI, they say that word a lot when they're looking through different chemicals and how much there is to help find the murderer. So now we're going to look at why mole. So atoms and molecules are just too small to count individually without using specialized equipment like a mass spectrometer or an extremely high definition microscope. But even for that, there's really no way to see that. And knowing the relationship between mass and the number of different atoms can allow for the determination of the number of particles in a sample by converting just this mass to mole. And that conversion can be done in a number of ways, and that's what we're going to be talking about today. So, molar mass. The mass of 1 mole of a pure element or compound uses a unit G over mole. Mole is simply abbreviated by MOL, and you read it the same way, G over mole. So the G over mole, basically the mass of 1 mole of a pure element or compound, and the atomic mass, U over atom, which we've seen before, is given by the mass given on the periodic table. So when you look at a periodic table, you look at your element, and underneath that element you have a mass. And both of those numbers are given by that mass number given at the bottom. So now we're going to look at the simple conversion of mass to moles and moles to mass. So when you're looking at the given mass, which for an example, okay, so I'm going to look at an example given in the lesson plan. The question is, how many moles of Cl are in a sample of 63.0 grams of Cl per mole, so over mole. Now the mass of Cl is 35.453 grams over mole. So that's what your mass equals. So we're going to take those given grams and we're going to multiply that by 1 mole over the molar mass. So the given grams is the 63.0 grams of Cl, and then the molar mass is the 35.453 grams over mole. Okay? So when we plug that into our equation, that's going to give us the number of moles. The answer to this question is 1.78 moles Cl. Now, as you can see on the PowerPoint, there are little asterisks, and those are given at the very end, not to mean mole, multiple, but to mean mole, and then insert at the bottom, it says insert symbol of atom here. The abbreviation of the atom should always go at the end, because then you're not going to know how many moles of which atom you're talking about, or which substance. And then it's not going to matter how many moles it is, because you're going to have no idea what you're talking about. So just an organization tip. So now we're going to go through an example of when we flip this the other way with the given number of moles. So the problem is, what is the mass of 3.25 moles F when the molar mass is equal to 18.998 grams over moles. So we're going to look at this problem and we're going to say, okay, what do we have? We have the given number of moles and we have the molar mass. What we don't have is the mass for grams. So obviously we're going to be using the second equation. Now, the given number of moles is stated here is 3.25. So insert that 3.25 where it says given number of moles. Make your cute little asterisk. And then on the top of this fraction, you're going to put this 18.998 number. Draw your little fraction sign, and underneath it, you're just going to have the number 1 mole, or you can just simply write 1. Now, when we multiply that out and divide that out, we're going to get the total mass. That mass should be equal to 61.7 grams F. As you can see again, we have the double asterisk within the parentheses that gives the abbreviation for the unit, and that again will just be whichever atom you're working with, whatever substance you're working with. And that's only this again is only used for pure substances up to this point. So you need a pure substance in order to do that. So now we're going to look at Avogadro's number. This number is very simple. This number the one that we're going to be using is 6.022 times 10 to the 23rd. We can abbreviate this for the use of this PowerPoint by AN. So wherever you see AN, you're going to insert the 6.022 times 10 to the power of the 23rd. So this number is different than molar mass. Remember that. It's definitely different, but it is the same for every atom. Okay, so once you write that number off, we'll be ready to start using it in conversion. Again, that number is 6.022 times 10 to the 23rd. Okay, so now we're going to talk about converting that number. It's a very, very long number. So the first equation says the given number of moles times the Avogadro's number over mole is equal to the number of atoms. And then you again have your unit. Atoms, double asterisk, insert name of element. So our first example for that one will be how many atoms of aluminum, Al, are contained in 3.73 moles. Okay, so we have a number of moles. The Avogadro's number and the 1 mole are always going to be the same, and we're being asked to find the number of atoms. So we're going to look at the first formula. The first formula, we're going to put in that 3.173 moles. When you're typing this in on a calculator, make sure to be careful about where you put your parentheses. And the easiest way to do that is between every signal, put a parentheses. Hopefully we can do a simulation of what the calculator would look like, if that is at all possible. If not, I can type that up and send that. Okay, so after we insert that 3.73 moles into our equation, and we do all that mathematical stuff, we're going to wind up with 2.25 times 10 to the 24th atoms aluminum. And there's your answer. So now we've taken the number of moles and we've found the number of atoms. Now, if we want to switch that around a little bit and we're given the number of atoms, but we don't know how many moles are in the equation, we're going to use that same fraction in the other one, that AN over 1 mole. We're going to take the reciprocal of that, and we're going to use the numbers given. So for this example, how many moles of PB are equivalent to 1.37 times 10 to the 12th atoms? Okay, so saying how many moles. That's the one thing we don't know. And it's giving us the number for atoms. So we're going to take that number, that 1.7.35, times 10 to the 12th, and we're going to plug that into our equation. When we do all the mathematics for that, we should come out with the answer of 2.24 times 10 to the negative 12 mole PB. And always remember to write in which element you're looking at the end with your atoms. So, final thoughts of this lesson. AN and molar mass both have the mole in common, and adding these two conversional steps together, the two steps that we talked about, that first one, which is just converting the gram over mole, and the second one with the Avogadro's number, if we add those two together, it's easy to work with and very effective. So here's our next example, converting grams to atoms. So, in order to convert grams to atoms, we can look at two different ways to look at this equation, depending on what we are given. We can talk about, so we're going to take this sample, whatever we're given, the mass of the sample, and we're going to put that in at the very beginning. You're going to take again your molar mass, and you're going to insert that underneath your first fraction, where it says molar mass G. Then you're going to just work that all out, and you're going to wind up with your atoms. But do you see two things in common? With a fraction, when any number is over another number, over the same number in a fraction, those numbers cancel out and become a 1. So you don't need to do math with those numbers. So as you can see with the second example, you can simplify this equation. You can look at the given mass times the Avogadro's number over the molar mass, and that will still give you the same number of atoms. This can make that equation a little bit easier, and it doesn't seem so overwhelming to do all the math. So there's your example of converting grams to atoms. Now, when we want to convert atoms to mass, so atoms to grams, we will be looking at a given number of atoms, and again, just finding mass, finding how many grams of that there are. So in this one, you'll take your number of atoms, you'll multiply that by your 1 mole over your Avogadro's number, then put your molar mass over 1 mole, multiply all of those together, all of those fractions and whole numbers, and then that will give you your mass in grams. Now, to shorten that one up, again, is this 1 over 1 fraction rule, and then you're just filling in basically just your variables, your given number of atoms, your molar mass, and your AN. And AN is always going to stand for, don't forget, that's 6.022 times 10 to the 23rd power, okay? And then when you work all of that out, you're going to wind up with your mass, and that's going to be again shown in grams, plus the name of the element. So thank you for joining us today. I hope you learned a lot and that the concept is clearer now. And if you have any questions, please do not be afraid to ask. Thank you. Have a wonderful day.